Let's talk about division, its definition, some related vocabulary, and some helpful representations. Division is closely related to multiplication, so we'll start with a multiplication problem and then interpret it from two perspectives. If I have 3 times 5 equals 15, then I could think of the 3 as the number of groups, and I could draw 3 groups. If I have 5 units in each group, then I populate each group with 5 units. And then finally, I can think about the answer, or the total number of units, as 15 total units. To turn this into a division problem, I would make one of the factors unknown. I could start by saying, what if I didn't know the number of groups? The division problem would become 15 total units divided by 5 units in each group leaves me with some number of groups where I'm trying to figure out how many groups I have. Or I could have pretended that I didn't know how many units in each group. Then the division problem becomes 15 total units divided by 3 groups equals some number of units in each group where I'm trying to find the number of units. This picture that I've drawn represents both of these. I could just erase the piece that I didn't know, but let's start from the beginning here and see what our pictures might look like if I started with 15 total units. So I've drawn 15 total units in each case. On the left, I know the units in each group, so I can start counting off. 1, 2, 3, 4, 5 units. And my question becomes, how many groups do I have? How many times can I circle 5 units? On the right, I have 15 total units, and now I have 3 groups. So I could draw out 3 groups, and the question becomes, how many units do I need to put in each group? We give names to both of these perspectives. So on the left, we might call it a measurement perspective because we knew how many in each group. We could measure out sets of 5 and then count the groups. We might call it a how many groups perspective because that's the question we're asking. And some books also call it repeated subtraction. On the right, we could call it partitioning because we're taking a total and we're partitioning it or breaking it into some known number of groups. Or we could call it how many in each group because that's the question we're trying to answer. Let's take care of some vocabulary and notation before we go on to the representations. When we're talking about division, the first number is the dividend divided by the divisor equals the quotient. When we use long division, the dividend goes under the long division symbol, the divisor is written to the left and the quotient on top. Or in a fraction representation, dividend over divisor equals quotient. So let's do a specific example of 15 divided by 3 is 5. 15 is our dividend, divided by 3 is the divisor, and 5 becomes the quotient. On the right here, the fraction perspective, 15 divided by 3 equals 5. The hardest one is where we use the long division symbol. So even though we say 15 first, we write it in the second position. So 15 divided by 3 equals 5. We don't read this as 3 divided by 15, even though that's the left to right order of the numbers. We read it as 15 divided by 3. Okay, let's go to some representations now. So in the end, if you know the dividend, the divisor, and the quotient, then you have the full picture and you can use any representation you want. But some representations are more helpful than others if you're trying to use the picture to solve the problem. So let's start with our repeated subtraction, measurement, how many groups perspective. 15 total units divided by 5 units in each group, and we're trying to find the number of groups. We might start with a discrete set model. This one I drew out 15 x's, and here I could say, well, 5 in each group, so let's start circling the groups. There's 5, there's another 5, and there's another 5. 1, 2, 3. I have 3 groups, and that's the answer to my division problem. The single number line is where the repeated subtraction idea comes in. We start at 15 and we repeatedly subtract off 5 until we get down to 0. How many times did I subtract off 5? I subtracted off 5 3 times. The double number line is a really neat one. So in this one, instead of starting at 15 and working backwards, I start at 0 and work forwards, like how when I circled my groups of 5 up here in the discrete set models. And on the second number line, I keep track. So some key features here is notice that we have the same spacing on each number line, and each number line starts at 0. My top number line is going to represent my units, and my bottom number line I'm going to use to count up the groups. So my first group of 5, I start at 0 and I circle 5 spaces. 5 complete spaces corresponds to 1 group. Another 5 complete spaces corresponds to a second full group. And finally, 5 complete spaces corresponds to a third full group. So my answer is 3 groups. There were no gaps or spaces between my groups. I represented all 15 spaces. Be sure that you're not getting sloppy and circling groups like this. We want to have groups encompassing full sets from including all of the spaces. All right, let's switch gears to the partitioning model, or the how many in each group. So bar models can be helpful, especially with big numbers. In this case, I would think about sum total 15 divided into 3 equal groups, and I'm trying to find out the value of each group. So once I know my division facts, rather than drawing out 15 objects, I can instead just think of this as 3 equal groups of 5. So how many are in each group? We have 5 in each group. The area model, here I have a 15 square unit model, and I need to break it into 3 groups. So I'm going to look here, and I'll have 3 total groups, and then I can count up 1, 2, 3, 4, 5, 5 in each group. Let's do a little practice. So we're going to start with 8 divided by 4 equals 2 versus 8 divided by 2 equals 4. We're going to use the partitioning where we know the number of groups and we're trying to figure out how many in each group. And we're going to do a bar model. So on the left here, I have 8 total. And I'm going to break it into, or partition it into, 4 equal groups. So I'm trying to find out how many objects are in each group. So in this case, I can see 2, 4, 6, 8 will be my answer. On the right, I can still start with 8 units, but now I've divided it into 2 equal groups, and the question becomes how much in each group? Well, now I have 4 in each group. Let's do one more. All right, now we're going to use the measurement repeated subtraction how many groups perspective, and we are going to use 8 divided by 4 and 8 divided by 2. So in this first problem on the left, I'm going to end at 8, and I know with the measurement perspective, I can count off groups of 4. So I'm going to circle 4 equal spaces, and that corresponds to one group. Another 4 equal spaces, and so I have a total of 2 groups. On the right, I still have 8 total, and I'm going to now circle groups of 2. So I'll have a group of 2 spaces. That's the first group. I'm keeping track on the bottom. Another group of 2 spaces. Another group of 2 spaces, and I'm just counting up my groups, how many groups on the bottom here, and I'm going to have 4 total groups.